Bio 20, welcome to the continuation of the story of the nephron. Today we're going to discuss about the different things that are secreted and absorbed into the nephron. So that's your learning intention today, understanding the role of reabsorption and secretion. Today, you will know that you have started down the path of understanding because you can explain what is being reabsorbed from each structure. So there's a lot of different materials being reabsorbed, and I'll talk about what the word reabsorb means here in a second and where it's being reabsorbed from. And then you should also be able to diagram or explain what things are being secreted. And again, we will be talking about that word secretion and what that means. So you have a chart in your notes that is like this, and essentially it goes piece by piece talking about the different things that are absorbed and secreted. Now, what I would like you to remember is that when I say reabsorption, so when I'm talking about reabsorption, reabsorption means I'm putting it back. Putting it back where? I'm putting it back into the blood, okay? We filter it into the kidney, and then I'm giving it back to the blood. So reabsorption is all about giving it back. Secretion means I don't want it anymore. Secrete it, get rid of it. Okay. So we want to secrete to excrete, meaning I'm taking it out of the blood and putting it back into the kidney. All right. So wherever you see reabsorption and secretion, the movement of the arrows, which I will explain in a second, is going to be different. Also within this chart, you'll notice there's a couple different colors. This is because it is showing the different ways that these ions and elements and stuff move across the kidney and the blood back and forth. There's active transport, which uses some energy, and passive transport, which is usually osmosis or diffusion. No energy, just going along a concentration gradient from high concentration to low concentration. So we're going to start today talking about the glomerulus and what its function is. You already know there is no specific arrows being drawn here, and I'll explain again what arrows I mean in a second. But what I do need you to do is write what its role is. So its role is filtration. And what happens is blood pressure coming up through the renal artery forces water and dissolved substances from the blood into the glomerular walls. Okay, so it goes from the blood into the glomerulus. From there, the Bowman's capsule captures all of that and makes that a filtrate. So it takes what's in the glomerulus and makes a filtrate out of it. That's the first two steps. From there, we enter into the proximal tubule. So the proximal tubule has a lot going on. So you can see the first part is all about reabsorption. So taking it from the kidney or the proximal tubule and sending it back to the blood. So actively, I am passing nutrients like glucose and amino acids back to the blood. I don't want them in my urine. It's not healthy for them to be in my urine. I need to give them back to my blood. My body needs them. I'm also doing the same with potassium, sodium, and calcium. I can have potassium, sodium, and calcium in my urine, but again, most of those are actually key elements that are needed for a variety of different processes. So I want to keep them in my body as much as possible. Due to the reabsorption of all of these ions, my solute is becoming very dense with substances. So water is going to passively transport from my proximal tubule back into my blood. When that happens, you're also going to get the following of negatively charged ions like chloride, which are attracted to something like sodium. Okay, they're going to follow passively because they're attracted to the positive ions that are now in your blood. So in the proximal tubule, I have a lot of movement of things going back into my blood. I have one thing that is being secreted from my blood back into my proximal tubule, and that is a hydrogen ion. Hydrogen ions are being actively passed into my proximal tubule. So that's the first part of the kidney. Right away, I take a lot of really good things and I put it back into the blood so that my blood can use glucose, amino acids, sodium, calcium, all these really good things. It needs it back in the blood to help my body run. We're now going to talk about the loop of Henle. So there's both the descending and ascending part of the loop of Henle. So when you're going down the loop of Henle, again, I'm going to take stuff out of the loop of Henle and put it into my blood. And what is that? It's just passive transport of water. So water is just slowly through osmosis moving back through to the blood. Pause here, make sure these are in your notes, and then we're going to move on to the next little bit. So the ascending loop. So now we're going up the loop of Henle. Again, in this point, the loop of Henle, we are going to reabsorb again. So putting things back into the blood. So you'll notice reabsorption is a big part of the loop of Henle. So what I'm doing is I'm moving sodium back into my bloodstream, and again, passive transport of the things that would be attracted, chloride and potassium ions. Now I'm at the top of my loop of Henle. I'm now into my distal tubule, and there's a lot going on in my distal tubule. This is kind of the last stop before it heads into the collecting duct to become urine. So what I need to do is make sure that I'm balancing all my substances. So again, sending back to my blood is sodium, water, chloride, and bicarbonate. Okay, so I'm sending all of that back into my blood through active and passive transport. I want to take back in hydrogen, some potassium, and maybe some chloride. Now, chloride just passes back and forth willy-nilly as you absorb sodium and then reabsorb sodium into your blood and secrete it back into the kidney. So again, the distal tubule is kind of making sure everything is intact before we go into the collecting duct. And the very last thing is the collecting duct's job is to ensure that water is not excreted if it doesn't need to be. Okay, so the collecting duct says, "Ooh, look at all this water I have. Do I need all of it?" And if it doesn't need it, it'll put it back into our bloodstream because it'll be like, "Oh yeah, you're kind of dehydrated. Here's some water." Okay. If it's not, it'll then be excreted. So reabsorbed back into the body, or it's just excreted. So this is the chart, and I kept talking about arrows. I kept saying, do some arrows. What does that mean? Well, I would like you to go back to the drawing of your nephron that you did the other day. It looks a little something like this. And you can see I have an arrow that shows active transport and an arrow that shows passive transport. At this point in time, I would like you to take the chart you had that we just wrote out, and I want you to label this nephron showing me the movement of things moving in and out. Okay, I'm going to show you a couple examples. I'm going to let you do it. I will post this later, the full answer key, so you can double check your work. So to start it off, we talked about the glomerulus being where we force everything into the Bowman's capsule that's going to be a filtrate, so water and dissolved substances. So it's being forced into the Bowman's capsule where it will become filtrate. Now, you will see this is how I am showing movement. So in my chart, I said that actively reabsorbed into the blood is glucose and amino acids. So that's what you're seeing right here is the movement of glucose and amino acids back to the blood. I also had in that chart a secretion of hydrogen ions. So secrete to excrete. So it's moving from here back into the kidney. Because both were blue in my notes, I know that they are active transport, meaning they need some energy. Sodium, potassium, and calcium are also being actively passed back into my bloodstream. And chloride is being passively transported. Water, passively transported. So what I've done for you is I have actually done the entire first part of the proximal tubule, showing you what I would like on your drawing. Active transport, dotted arrows, passive transport, solid arrows. How do you know which one's which? Color coordinate it like I did in my notes. When I say reabsorb, it moves to the blood. When I say secrete, it means to the kidney to excrete. So I want you to fill the rest of this out, and we will look at it and discuss it later.